Dear students, welcome to the second online class. Now we'll be talking about the different compounds and their effect on the global warming and the pollution. The different types of pollution. First one you can see, I'm talking about lead. First one I will be talking about lead. This you can see lead in front of you with the antinok compounds. What is given is antinok compounds. This is lead I'm talking about, and this is antinok compound. There is A is major contributor, B is secondary influence. So when lead is used as antinok compound, it is the major contributor in case of SI engine as an antinok compound. So it decreases knock to a large extent. But problem is that lead is poisonous. So that creates a lot of problem for human beings. Then second is carcinogens. Carcinogens is cancerous. This comes out of diesel exhaust. Let me go out of this. This is carcinogen. You can see this. This comes from diesel exhaust, and it is a major contributor. Carcinogens means it produces cancer within people, so it is dangerous. You can understand that. And for that reason, diesel car is getting a strict no-no in different places. In Delhi also, they are banning diesel car by the day. So that is what is to be seen. Then comes acid rain. We'll come to the next one. This is acid rain. Acid rain is a phenomenon which doesn't happen in our country in general. It happens in Western countries more. Acid rain happens due to principal sources of sulfur oxide, sulfur dioxide, oxides of nitrogen, unburnt hydrocarbons, carbon monoxide. You can see all of these are high polluting agents. When the acid rain happens, as a result of that, the whole environment gets acidic, the water gets acidic, the houses get corroding effect due to acidity, and this has got different connotations. You can see, like sulfur dioxide is secondary contributor or secondary influence for CI engines. In case of CI engines, it produces secondary influence. Oxides of nitrogen is a primary influence. You can see here, oxides of nitrogen. Unburnt hydrocarbons, again a primary contributor, and this is for SI engines. That is why in a car, the total burning or total combustion is very important. If the total burning or total combustion is not there, as a result of that, the unburnt hydrocarbon comes along with the exhaust, and it works as a major contributor for acid rain. Then comes carbon monoxide, also a major contributor for SI engine, which is again responsible for acid rain. Not only acid rain, carbon monoxide is bad, very bad for human body too. It directly attacks our respiratory system. Other than that, then comes global warming. Which are causing global warming? Number one, you can see I am now putting the global warming into the picture. This is global warming. You can soon see number one is CFCs. CFCs are major causes of global warming. Now, how does CFC does the global warming? CFCs generally react with ozone layer in the environment. As it reacts with ozone layer in the environment, as a result of that, the ozone layer in the environment gets affected. It reacts with CFC and breaks. And because of this breaking, a hole is created in the ozone layer. And through the hole, ultraviolet ray of sun comes inside. And ultraviolet ray is one of the major contributors in producing cancer. Skin diseases, skin cancers. It's dangerous for the global warming. It's dangerous for human health. The ozone layer at the top environment saves us from the ultraviolet ray. It doesn't allow ultraviolet ray of sun to enter into the earth's surface. As a result of that, we human beings are well protected. But when CFCs react with ozone layer, as a result of that, the ozone layer breaks. The breakage happens as a result of production of oxygen, and the ultraviolet ray enters inside. There is a big hole in the ozone layer in Antarctica zone, as a result of which a big part of the earth is being affected. Luckily, that is not a populated part, being in Antarctica. It would have been in populated places like India or Europe. It would have got catastrophic effect. Then comes carbon dioxide. Carbon dioxide is always responsible for global warming. Carbon dioxide is responsible for global warming in the sense it doesn't allow the reflected sunlight to go outside. So the sunlight remains inside, makes it a warm gas house like thing, the earth. The temperature increases, and you know the temperature is increasing by the day. And if the temperature increases by 2 degrees centigrade, the scientists tell all the low-lying places and seashore places like Mumbai, like other seashore places like Maldives, Mauritius, all will go under water. Because as a result of carbon dioxide, if global warming increases and temperature increases by 2 degrees, the glaciers will melt. And as a result of melting of glaciers, a big part of sea level will rise. Already, a large part of glaciers is being melted. And as a result of glacier melting, lots of water level increase happening in the sea, which is becoming dangerous, more and more dangerous for different nations in the world. Photochemical smog. This is our Delhi is very affected by that. If you take this, okay, I missed one thing. Methane. I should talk about methane. There is in global warming. Methane also plays a very important role in global warming, and methane is largely contributed by CNG, though it is a secondary influence, but has got a big effect. And CNG, you know, in many cities in the world, including Delhi, uses CNG, and lots of methane are being emitted. And this methane is responsible for global warming. So even if you come out of hydrocarbons, petroleum fuels, gasolines, even with CNG, there is problem of global warming. But even if it is better than diesel exhaust, petrol exhaust, that it is not producing cancer and such other things. The only negative effect being the global warming. Then comes petrochemical smog. That comes carbon monoxide. This is a primary contributor for the SI engine. Carbon monoxide creates a lot of smog in Delhi. You know what is smog? Smog is an environment you find before winter or during winter. You see the whole sky in Delhi remains hazy. You cannot see in tremendous haziness condition even a small distance. This is due to smog. As a result of that, it produces lot of pollution effects and affects the respiration system of human beings. You must be knowing a large part of patients in Delhi hospitals are respiration patients. They're suffering from respiratory problems. This is because of these emissions of the cars and vehicles. Then we have unburnt hydrocarbons. When hydrocarbons don't burn properly in SI engines, the unburnt hydrocarbons come out and they produce smoke. This is another reason of another unburnt hydrocarbon which produces smoke, photochemical smoke. And this is a primary contributor for the SI engine. Then comes sulfur dioxide. Sulfur dioxide is for CI engine. It produces smoke too. Then oxides of nitrogen. It is emitted by both SI engine and CI engine, and it has got primary effect and produces a lot of smog in the environment. Then ozone depletion. I was talking about global warming. Now coming to ozone depletion. For CFCs, just now I explained about the ozone depletion, how it happens. As a result of ozone depletion, the ultraviolet ray comes inside and the global warming happens, and skin cancer and such other diseases happen. This is written a major contributor for car with AC. That's the secondary influence. But I will tell you, nowadays all the cars come with AC. There is no car without AC. So CFCs play a very important role. As a result of that, in refrigeration industry, you'll come to know when you come to 7th semester and you read refrigeration air conditioning. In refrigeration industry, lots of CFC gases are being replaced. CFC gases means you must have heard the names of R11, R22. These are the main two gases which are used as CFCs. And these are replaced by R40, 410A and such other gases. You can see the latest split AC or window AC you are buying clearly indicates the name of the refrigerant written on that. Because CFCs are no more allowed in split and window ACs and other air conditioning systems worldwide. Unburned hydrocarbon also creates ozone depletion, a big cause of ozone depletion, and then oxides of nitrogen. So what we see, there are so many negative effects as a result of that. First is lead pollution. That is what is lead, which is a poisonous substance, is being inhaled by us and we get ill. Carcinogens, which produces cancers. Acid rain. Because of lot of acid rain, there is pollution in the environment. The water gets affected. The digestive system gets affected. Global warming. The temperature of the earth is increasing continuously. Photochemical smog happens in winter conditions in Delhi, the hazy environment. Ozone depletion, a big cause of skin cancer and other things due to incoming ultraviolet rays. Exhaust emission control. How do you make the exhaust emission control? There are very few basic methods for exhaust emission control. First is engineering of the combustion process. We should properly engineer the combustion process. That means the combustion chamber itself is designed in such a way so that the NOx, sulfur dioxide and other emissions are very less. Carbon dioxide, carbon monoxide, all these. This is possible to a large extent when there is a proper burning of air-fuel mixture inside. For proper burning of air-fuel mixture inside, the spark plug in case of SI engines should be at the middle of the engine. And the spark plug should be confined in a small space so that the total combustion happens. In case of SI engines, this is possible because SI engines are generally smaller engines. But in case of CI engines, it sometimes becomes difficult. Optimizing the choice of operating parameters. We can choose different operating parameters. We can increase the speed, we can decrease the speed. We can go with particular fuel length, air-fuel ratio depending on the speed parameters. We know what is the green zone in the speed parameter of the engine and we can run the car in the speed parameter. We try to minimize while the car is running in the red light condition. In the red light, we'll off the car, put off the car so that no emission is there, because during idling period in red light, the emission is maximum. So we can decrease it by making the car off, the engine switch off. And then using after treatment devices in the exhaust system. After treatment devices in the exhaust system. That means in the exhaust, as the gas goes out, we can put some treatment system through which the exhaust gases will pass, and as a result, the poisonous substances, the pollutants, carbon monoxide, carbon dioxide, and NOx, and whatever other pollutants, hydrocarbons, unburnt hydrocarbons, all these other pollutants can be decreased using certain materials. We'll talk about that in the next slides. Using reformulated fuels, for example, fuel with oxygenated gasoline in winter to reduce CO. Oxygenated gasoline means what? When you use oxygenated gasoline, more oxygen will be produced and CO2 will be produced instead of CO. CO2 is compared to CO is better. CO is very, very hazardous. CO affects our respiratory system. It's a poisonous substance and affects our health in totality. So CO is to be removed. Low volatility gasoline in summer to reduce evaporative hydrocarbon. Because of summer high temperature, the hydrocarbon or the fuel gets evaporated. The evaporated fuel gets mixed into the environment. We inhale the gas. That means we inhale the HC along with the oxygen of the air. Our health is affected. There are many other negative effects I have just told in the previous slide. This requires advances in fuel injector design. Very important, fuel injector design. You can design the fuel injector in case of CI engine in different ways, or you can place the spark ignition points. That's the where the ignition happens. I mean to say, this is to be placed. This can be placed in a central location so that the total combustion happens. Similarly, the fuel injector in case of CI engine can be placed in central places so that the fuel doesn't have to travel a much distance or a corner of the cylinder where the chance of knocking is more. Because in case of diesel engine, the unburnt gases produce knocking. Oxygen sensors, lot of oxygen has to be there. You have to see in air fuel mixture, the more of air, more of oxygen. The leaner the mixture, better it is for pollution. So you try to use lean mixture. Lean mixture means what? Air is more, fuel is less. Air more means what? Oxygen is more. So you can have an oxygen sensor in the car which senses oxygen continuously and accordingly makes the air fuel mixture opens in carburetor in case of SI engine. It can control that, seeing the oxygen sensors, allows more air to come as compared to fuel. As a result of that, proper air fuel mixing happens and more oxygen comes. More oxygen means, say example, just now I have told carbon monoxide gets converted into carbon dioxide. As a result, carbon dioxide is a less pollutant as compared to carbon monoxide. Onboard computers make the total car system computerized, which senses all the computers, give a signal to a particular part to work accordingly. For example, oxygen sensors get a sense of oxygen. It senses oxygen. If the oxygen is less, it gives signal to the computer. Computer gives signal to carburetor. Carburetor controls air fuel mixture accordingly to increase the oxygen. That means it sends a leaner mixture as compared to rich mixture when the oxygen quantity drops. So these are different effects used in case of engines. Now NOx. NOx control measures have been in since 1970s, namely spark return and exhaust gas recirculation. We can make the exhaust gas recirculation. This is one of the very important parameters. What happens in exhaust gas recirculation? When you make the exhaust gas recirculated, as a result of that, the temperature remains high. So the intensity of spark to be produced or intensity of compression ignition to be produced becomes less. Because the fuel itself is in higher temperature condition. So it burns easily, the combustion happens easily. Both methods reduce peak temperature and hence NOx emissions. Peak temperature reduces as a result of that, and NOx emission happens. Peak temperature reduces with NOx emission decreases. It doesn't happen, it decreases. If exhaust gas recirculation is used, spark timing has to be advanced to maintain optimal thermal efficiency. Why spark timing has to be advanced? Because if the spark timing happens as usual, then the moment you put a high hot gas, immediately blast happens. But in an engine, you need some amount of ignition delay. You need some amount of ignition delay so that the total combustion of gases happen. So using the exhaust gas recirculation, we can make the spark timing to be advanced so that it takes some time to get into combustion mode. Remember that exhaust gas is already in a high temperature. Then exhaust gas recirculation increases with engine load up to the lean limit, about 15 to 20% of the fuel air mixture. 15 to 20% fuel air mixture. Remember, not air fuel, it is fuel air mixture. Fuel is only 15 to 20% of the total mixture. That means air quantity is quite high. That is to be taken care of in case of EGR. Air quantity high means oxygenated product will come out. More oxygenated product, exhaust comes out, means less of pollution. These are the different parameters we use while we use in case of pollutants. There are three-way catalysts consist of rhodium, the principal metal used to remove NO, there is nitrogen oxide and such other materials which are negative for the environment. The metal reacts with nitrogen oxide and removes it. Platinum, the principal metal used to remove hydrocarbon and carbon monoxide. Hydrocarbon and carbon monoxide are the worst of the pollutants emitted. Platinum is very costly metal, but even then it is to be used to remove hydrocarbon and carbon monoxide. NO reacts with CO, HC and H2 via reduction reactions on the surface of the catalyst. Catalyst, like, what do you mean by catalyst? Means catalyst which reacts, which helps in reaction, like rhodium, like platinum. These work as the major materials on the surface, through the surface of which the exhaust gases pass. And as the exhaust gases pass, they react with them and they get converted into oxygenated products. Like it's written, CO and HC, means carbon monoxide and hydrocarbon, are removed through oxidation reaction, forming carbon dioxide and water in the products. I said already, carbon dioxide is not that bad pollutant as carbon monoxide. And also, water it produces. So water is good for the environment. So we can convert the dangerous elements like carbon monoxide and hydrocarbon into carbon dioxide and water in our products. Then comes a technical term, light of temperature, the temperature at which catalytic converter becomes 50% efficient. It is approximately 270 degrees centigrade for oxidation of HC and about 220 degrees centigrade for oxidation of CO. That means a minimum temperature is to be attained to make these catalytic converters functional. That means as the car moves for a long time, the temperature increases in the exhaust more and better the catalysts function. Conversion efficiency at fully warmed up condition is 98 to 99% for carbon monoxide and 95% for hydrocarbon, depending on hydrocarbon components. It's around 98 to 99% carbon monoxide conversion efficiency. See, the conversion efficiency is so high. For carbon monoxide, it is nearly 100%. That means it produces almost all the carbon monoxide into carbon dioxide. And 95% for hydrocarbon means a lot of water is produced out of hydrocarbon. Now, Catalytic converter consists of an active catalytic material in a specially designed metal casing which directs the exhaust gas to the catalyst pad. Catalyst generally remains in a bed. Bed means a flurry of metals through which the exhaust gases will pass. The flurry of metals may be in form of pellet beds, may be in form of honeycomb. In case of a honeycomb, they remain in a particular structure, small cell-like structures throughout. So what happens? The more and more of surface area gets exposed to the environment. That makes the honey more and more oxygenated. So that is so healthy. So the honey is so healthy. Keeping the same into our mind, we keep more and more surface area exposed to the exhaust gas so that the catalytic converter reacts more. We have noble metals like platinum, palladium, rhodium, or base metals like copper and chromium. These are all different active materials. Now, there are particular reactions happening with these metals of the exhaust gases. As engineers, we need not go into the details of the reactions. That's the part the chemists will see it. We are more bothered, the pollutants are reduced. We are more bothered into that part. Our specific role is contained in that. Of course, if you are interested in research and such other studies, then you can go into the more details of this, what types of atomic reaction takes place, what type of molecular reaction takes place, what is the effect of that, what are the products. But being a mechanical engineer, we remain ourselves restricted to finding out how we can reduce the pollution to the maximum. Two types of configurations are mostly used: ceramic honeycomb or matrix structure, also called monolith, and a bed of spherical ceramic pellets. Now, honeycomb structure, I have said, more surface area exposed. If you make a honeycomb structure, pass exhaust gas through it, the more and more surface area gets exposed. The more surface area gets exposed means, as a result of that, more reaction. I said, in a honeycomb structure, you see in a honeycomb, what happens? In case of bees, make the honeycombs in such a way that more and more surface area remains oxygenated. It makes the honey more healthy. Just I was explaining that to you. In the same environment, same thing here. It works in a monolith and it produces a very good honeycomb structure, produces more and more reaction. That means we are using the maximum of the metal surface to react with the exhaust gases to make a proper honeycomb structure. A bed of spherical ceramic pellets. You make a bed of pellets. Through the bed, you make the exhaust gases to go. And as the exhaust gases go through the bed, there is conversion. Conversion into water, conversion into oxygen. More of carbon dioxide, more of water, more of oxygenated product, and less of pollution. Catalyst poisoning or degradation may be due to the following causes. Overheating due to engine malfunction. If the engine malfunction increases, say the temperature of the engine increases tremendously. So, as a result of too high a temperature, it will destroy the catalyst. I said the catalyst should have a temperature of about 270 degrees centigrade minimum to 50% operative. That's true. But if the temperature is too much, say it is increasing to 700, 800 degrees centigrade, that it will kill the metal. The material properties of the metal. It won't react. And as a result of that, there will be no carbon dioxide and no water produced. In case of hydrocarbon and carbon monoxide passing through it. The efficiency drops to 40% in 10 hours of operation. Efficiency drops to 40% when there is lead content more in the fuel. The efficiency drops to a larger extent. the efficiency drops more in case of more lead, because as a result of that, the efficiency decreases continuously of the product. That means if you drive the car for very long time, say 10 hours you're continuously driving, the fuel or the exhaust will give more pollutants. There is a limit up to which you can drive continuously. If you drive continuously more for a longer hours of operation without giving rest to the engine, as a result of that, and in the fuel is having lots of lead in that, as a result of that, the performance of the catalyst decreases severely. Sintering is promoted by exposure of catalyst to high operating temperatures, involves migration and agglomeration of sites, thus determining their active surface area. Migration and agglomeration of sites means मतलब high operating temperature में the sites, that means the honeycomb structure they are having continuous, will move from one place to another because of the atoms and molecules get dispersed in the structure at the high temperature. Because of this dispersion,